Hi everyone. I'd like to now talk about an example for conducting the hypothesis testing for a population mean. So here are the major 5 steps. So these 5 steps are the same 5 steps as the one we see earlier for testing the population proportion. So here's our problem. A public bus company official claims that the mean waiting time for bus number 14 during peak hours is less than 10 minutes. Karen took bus number 14 during peak hours on 18 different occasions. Her mean waiting time was 7.6 minutes with a standard deviation of 2.3 minutes. At the 0.01 significance level, test the claim that the mean waiting time is less than 10 minutes. Assume that a simple random sample has been selected from a normally distributed population. So let's look at this problem again. So there are quite a couple different numbers here. Some number we actually do not have to use them. So let's take a look. First of all, bus number 14. So that's the bus number, which is more like a categorical not a variable, but categorical measurement here, which we don't have to worry about it. But the bus company claimed that the mean waiting time is less than 10 minutes, so that is our claim. Later we need to put that into our hypothesis. And then Karen took this bus, which is bus number 14, on 18 different occasions. So this will be our sample size. And then her mean waiting time from those 18 different occasions is 7.6 minutes. That will be our X bar, or sample mean, with a standard deviation of 2.3 minutes. So that will be our sample standard deviation. And then our alpha, our significance level, is given to be 0.01. Okay, and here we're assuming a simple random sample and a normal distribution for our population. And we do not know what sigma is. But we do know the population has a normal distribution, so we'll be using the t distribution in this problem. Okay. So now for the hypothesis. So the claim is that the mean waiting time is less than 10 minutes. And because it's a strict inequality, less than, so that will be put under the alternative hypothesis. So the null hypothesis will be equals. So mu equals 10. So this is our hypothesis. Then for the test statistic, so now we're using a t distribution. Again, because first of all, we don't know what the population standard deviation is. And we're given a sample standard deviation. And second, our underlying distribution of the population is said to have a normal distribution. So because of these, then we use the t distribution. So do not use the normal distribution for this problem. So we have x bar minus mu over s over square root of n. So just plug in those numbers and you will get your test statistic as t equals negative 4.427. Then find the p-value or the critical value. So again, in the test, I will only ask you to do one of them. But here I like to present both, so then you know how to do both of them. All right, so because this is a left tail test, under the alternative hypothesis, we have a less than notation. So our p-value is the probability where t is less than this test statistic, negative 4.427. So here, use your calculator to find this p-value. If you use your table, you can only estimate a range of that. And I don't want to go too much into that because I think it's more important you know how to use your calculator to find this particular or this exact p-value. All right, so let's use a function we haven't used before. So go to second vars. Yeah, we've been there before, but now for the function I want you to look at is the t-CDF. So the input is very similar to the normal CDF function, except now this is a t distribution. So we still put a lower bound and an upper bound. In this case, the lower bound will be a very small number, so negative 10 to the power of 10. And then the upper bound will be the test statistic, negative 4.427. Then one more input will be the degrees of freedom. So the sample size in this case is, let's just go back one slide. So it's n equals 18, which tells us the degrees of freedom is 18 minus 1, or the sample size minus 1. So we put a 17 here. Okay, so then that's your, so if you round it to 4 decimals, so it will be about 0.0002. So this is to use the TCDF function. Then to find the critical value, so refresh your memory in chapter 7, so go to table A3 to find this critical value. So you should get t equals negative 2.567. Okay, so after that is done, then now decision. So for the p-value method, we're comparing the p-value with alpha. In this case, the p-value is 0.0002, alpha is 0.01, so our p-value is smaller than alpha, which will lead us to reject the null hypothesis. And then for the traditional method, so a critical region would be t less than negative 2.567. And because our test statistic is smaller than that, which is in the critical region for this left-tail test, so we also reject the null hypothesis. So again, if you do not remember this criteria, go back to section 8.2's note. Okay. And whichever method you use, which I will specify in the test, but both methods should lead to the same conclusion, otherwise something is not correct. Finally, for the conclusion, so again, we have a conclusion template in section 8.2's note. So in this case, this is how we draw our conclusion. So we start with, there is sufficient evidence to support the claim. This is from the template. And then after that, filling the rest by the problem. So the claim is the mean waiting time is less than 10 minutes. So that's it for your conclusion.